National Electrical Code, or NEC, contains specific requirements regarding overcurrent protection in electrical systems, particularly concerning subpanels. Article 312.8 states that overcurrent protection must be provided at every point where a conductor enters a panel board or similar enclosure. This applies if the conductors aren't already protected by the feeder overcurrent device. Article 408.5 specifies that a disconnecting means shall be provided on the supply side of each generator. Furthermore, Article 408.5d clarifies that this disconnecting means should consist of a circuit breaker, switch, or other approved device. These articles, interpreted together, establish the NEC stance on subpanel protection. The code mandates that all conductors entering a subpanel must be protected by an overcurrent device. This typically translates to the necessity of a main breaker or an equivalent disconnecting means installed within each subpanel. The primary function of a main breaker in a subpanel is twofold. Firstly, it serves as a disconnecting means, and secondly, it provides overcurrent protection. This breaker allows for the isolation of the subpanel from the main distribution panel, or MDP, which is crucial for maintenance purposes or during emergencies. Without a main breaker, there is no local way to quickly de-energize the subpanel, potentially creating hazardous conditions for personnel working on the system. The NEC requirement for overcurrent protection is rooted in safety. Overcurrents, such as short circuits or overloads, can cause conductors to overheat, leading to insulation damage, fires, and equipment failure. Overcurrent protection devices, like circuit breakers and fuses, are designed to interrupt the flow of electricity when an overcurrent condition is detected, preventing these hazards. When conductors are terminated directly to bus bars in a subpanel without a main breaker, they lack this crucial overcurrent protection at the point of entry to the subpanel. The feeder breaker in the MDP provides some level of protection, but it may not respond quickly enough to clear fault within the subpanel itself. Furthermore, the feeder breaker may be sized to protect the entire feeder circuit, not just the subpanel conductors, potentially allowing a smaller overcurrent within the subpanel to persist for a longer period, leading to damage. The disconnecting means requirement is equally important. A disconnecting means allows for the safe isolation of a circuit or piece of equipment for maintenance or repair. Without a disconnecting means at the subpanel, any work on the subpanel or branch circuits would require shutting down the entire feeder circuit at the MDP, affecting all other loads served by that feeder. This can be disruptive and inconvenient, especially in critical facilities where downtime must be minimized. The NEC recognizes that there are different ways to provide overcurrent protection and a disconnecting means. While a main breaker is the most common and straightforward solution, other approved devices, such as fuse switches, can also be used. However, any alternative solution must meet the same safety and performance requirements as a main breaker. The specific size and type of main breaker required for a subpanel will depend on the size and type of conductors feeding the subpanel, as well as the anticipated load. The breaker must be sized to protect the conductors from overcurrent, but it must also be large enough to handle the normal load of the subpanel. NEC Table 310.15 provides ampacity ratings for various conductor sizes and types, which can be used to determine the appropriate breaker size. In addition to the NEC requirements, local codes and regulations may also have specific requirements for subpanel installations. It is important to consult with a qualified electrical inspector or engineer to ensure that any subpanel installation complies with all applicable codes and regulations. Proper installation and maintenance of subpanels are critical for electrical safety. Subpanels should be installed in a dry, accessible location, and they should be properly grounded and bonded. All connections should be tight and secure, and the panel should be labeled clearly to identify the circuits it serves. Regular inspections should be performed to check for any signs of damage or deterioration, and any problems should be corrected promptly. In summary, the NEC requires that all conductors entering a subpanel be protected by an overcurrent device, and that a disconnecting means be provided to isolate the subpanel from the main distribution panel. A main breaker is the most common way to meet these requirements, providing both overcurrent protection and a disconnecting means. The practice of terminating cables directly to bus bars without a main breaker in sub-panels is not permitted by the NEC. Proper installation and maintenance of sub-panels are essential for electrical safety. Therefore, it's essential to ensure compliance with NEC and local codes when installing or modifying electrical systems. Sub-panels play a vital role in distributing power throughout a building, and their proper function is critical for the safety and reliability of the electrical system. An understanding of the NEC requirements for sub-panels is essential for electricians, electrical contractors, and anyone involved in the design, installation, or maintenance of electrical systems. The NEC is a comprehensive set of standards that is updated regularly to reflect the latest advances in electrical technology and safety practices. Staying up to date on the latest NEC requirements is essential for ensuring the safety and reliability of electrical systems. The main breaker in a sub-panel not only provides overcurrent protection and a disconnecting means, but it also enhances the overall safety and reliability of the electrical system. By isolating the sub-panel from the MDP, the main breaker can prevent faults within the sub-panel from affecting other parts of the system. This can be particularly important in critical facilities where even a brief power outage can have significant consequences. Furthermore, the main breaker can simplify troubleshooting and maintenance. By disconnecting the sub-panel from the MDP, technicians can safely work on the sub-panel and its branch circuits without having to shut down the entire feeder circuit. This can save time and minimize downtime, especially in complex electrical systems. The NEC requirements for sub-panel main breakers are not arbitrary. They are based on decades of experience and research, and they are designed to protect people and property from electrical hazards. By following the NEC requirements, electricians and electrical contractors can ensure that electrical systems are installed and maintained safely and reliably. It's also important to remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to meet specific project needs or to enhance safety and reliability. For example, in a critical facility, it may be desirable to install redundant power supplies or to use higher rated components to minimize the risk of failure. The decision to exceed the NEC requirements should be based on a careful assessment of the risks and benefits, and it should be made in consultation with a qualified electrical engineer. In addition to the technical requirements of the NEC, it's also important to consider the human factors involved in electrical safety. Electrical work can be dangerous, and it's essential to follow safe work practices at all times. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using properly insulated tools. It also includes de-energizing circuits before working on them and verifying that they are de-energized using a reliable test instrument. Finally, it's important to be aware of the potential hazards of electricity and to take steps to mitigate those hazards. This includes avoiding contact with energized parts, keeping work areas clean and organized, and reporting any unsafe conditions to a supervisor. By combining a thorough understanding of the NEC requirements with safe work practices, electricians and electrical contractors can ensure that electrical systems are installed and maintained safely and reliably. The NEC is a living document that is constantly evolving to reflect the latest advances in electrical technology and safety practices. Staying up to date on the latest NEC requirements is essential for anyone involved in the design, installation, or maintenance of electrical systems. There are many resources available to help electricians and electrical contractors stay current with the NEC. These include NEC handbooks, training courses, and online forums. It's also important to attend industry events and conferences to learn about the latest trends and technologies in the electrical industry. By investing in ongoing education and training, electricians and electrical contractors can ensure that they have the knowledge and skills necessary to perform their jobs safely and effectively. The NEC is not just a set of rules, it's a guide to best practices for electrical safety. By following the NEC, electricians and electrical contractors can help to prevent electrical accidents and save lives. The information presented here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before undertaking any electrical work. Sub-panels are integral components in modern electrical distribution systems, serving as localized distribution points for branch circuits fed from a main distribution panel. Their proper design, installation, and maintenance are critical for ensuring the safety and reliability of electrical power within a building or facility. Let's delve deeper into some key aspects related to sub-panels and their associated electrical considerations. Firstly, sub-panel sizing. The size of a sub-panel, measured in amps, must be adequate to handle the anticipated load of all the branch circuits it serves. This calculation involves summing the continuous and non-continuous loads of each branch circuit, applying demand factors where appropriate, and ensuring that the sub-panel's ampacity rating meets or exceeds the total calculated load. Secondly, feeder conductor sizing. The conductors feeding the sub-panel from the main distribution panel must be sized appropriately to carry the calculated load. NEC Table 310.15 provides ampacity ratings for various conductor sizes and insulation types, considering factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable. Thirdly, overcurrent protection. As previously discussed, the NEC mandates overcurrent protection at the point where conductors enter a sub-panel. Typically, this is achieved using a main breaker within the sub-panel sized to protect the feeder conductors and the sub-panel's bus bars from overcurrent conditions. Fourthly, grounding and bonding. Proper grounding and bonding are essential for electrical safety. The sub-panel enclosure must be grounded to the building's grounding electrode system, and all metallic components within the sub-panel must be bonded together to create a low impedance path for fault currents. Fifthly, branch circuit protection. Each branch circuit originating from the sub-panel must have its own overcurrent protection device, typically a circuit breaker or fuse, sized to protect the branch circuit conductors and the equipment they supply. Sixthly, neutral and ground separation. In a sub-panel, the neutral and ground conductors must be kept separate. The neutral conductor carries the unbalanced current from the load back to the source, while the ground conductor provides a path for fault currents. Connecting the neutral and ground conductors together in a sub-panel can create a parallel path for neutral current, leading to potential safety hazards. Seventhly, labeling and documentation. All circuits within the sub-panel must be clearly labeled to identify their purpose and the loads they serve. Accurate documentation, including panel schedules and wiring diagrams, is essential for troubleshooting and maintenance. Eighthly, physical location. Sub-panels should be located in readily accessible locations free from obstructions and environmental hazards such as moisture or excessive heat. Ninthly, workmanship. Electrical work within a sub-panel must be performed by qualified individuals in accordance with industry best practices. Proper wire terminations, secure connections, and attention to detail are essential for ensuring the long-term reliability and safety of the electrical system. Tenthly, periodic inspections. Regular inspections of sub-panels are crucial for identifying potential problems such as loose connections, corrosion, or damaged component. Addressing these issues promptly can prevent more serious problems and ensure the continued safe operation of the electrical system. The NEC provides detailed guidance on many aspects of sub-panel design, installation, and maintenance. It is essential to consult the NEC and other relevant standards to ensure that all work is performed in accordance with applicable codes and regulations. Furthermore, local codes and regulations may impose additional requirements beyond those specified in the NEC. It is always advisable to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. Sub-panels are critical components of electrical distribution systems, and their proper function is essential for the safety and reliability of electrical power. By understanding the key electrical considerations associated with sub-panels and adhering to applicable codes and regulations, electricians and electrical contractors can ensure that these components are installed and maintained safely and effectively. Remember to always consult the latest edition of the National Electrical Code and local regulations for the most up-to-date requirements and guidelines. Electrical work should only be performed by qualified and licensed electricians to ensure safety and compliance.